Convergence, convergence, convergence. When our network converges, what happens? So, convergence is nothing more than our devices exchanging routes, exchanging packets, traffic's traversing from point A to point B, the network settled down, doing what it's supposed to do, and everybody's happy. So, let me set up this here quick extended ping. All right, so while I just broke that link, so we got a BGP environment sitting here, which basically looks like this right here. It's real simple, nothing fancy. I got router J4, got router J3 here, and I got, let's see, this is a 15 network up here, and this is a 10 dot network down here. So basically what I did was, as you see these pings down here on my J3 router, they're dead in the water. So all I did was basically I broke the link on J4, which was my 15 network right there. I just broke that link. So basically what's happening right now between these two routers, if this was an actual real world environment, traffic on this site would basically be black holed at this point, dropped, whatever you call it. But basically that's what's happening. Packets are being dropped. Okay. Now the thing about convergence, like I said, this isn't a converged network right here. So what's happening, or what we need to do, is have a backup plan. Now, how do we get something like BGP to converge faster? We can change the timers. We can put in backup links, which is the topology you see here with this 15 network and this 10 network. But right now we are at the mercy of the timers, the BGP timers. So if we look at, let's see, this time isn't correct, but let's just say, all right, 8:53. Now you see now we got our pings going back through. So let's do this. Show clock. So basically what you saw here was the two routers, this here simple network basically reconverged, okay? And it took approximately a little over 2 minutes, which is basically what the whole timer for this here BGP setup is at. So what happened was we basically did a reconverge, the system reconverged, and everything started to go back across this here second link across this 10 network. Now, what I want to talk about is a little protocol known as bidirectional forwarding detection, or BFD as it's called for short. And what this does, this isn't a part, this is separate from BGP or EIGRP or OSPF, whatever protocol that you may be running. It's separate from that, and what it does, it works outside of the protocol. And in essence, what it will do is it will actually detect the forwarding path failure, and then it will turn around and it will tell the protocol, whatever protocol you're utilizing, it will tell the protocol, hey, this link is down. There's no need for you to wait out this timer. We can go ahead and we can kill this link and reconverge maybe with a backup link right now instead of waiting for the timers. So as you saw, the amount of time that I was taking to explain about the convergence, you saw where the network basically dropped, and then and it dropped here, and then it picked back up. Okay, roughly 2 minutes later. Well, 2 minutes, as you know, in the IT world, can be like forever. So when we implement this here BFD, there's a couple things that we need to think about. BFD has a couple components that we have to add to make this work. First of all, the BFT to set this up, you have an interval time frame, okay, that you need to add into this here interface, the interface that are in question. These could be LAN interfaces, WAN interfaces, whatever you see fit to run this on. And what you'll see is that you have a timer, okay, that it will send out these basically hello packets, okay, to the other side to see if it's there. Basically, if you can think about how hello packets work, okay. Now we're talking sub-seconds, okay. We're talking sub-seconds when this is actually happening, okay. And after a certain period, or I should say a certain amount of dropped or no responses, is when BFT springs into action and notifies the protocol that, hey, we got a problem. I can't connect to the other side, to my neighbor. You need to go ahead and kill this process. Okay. And the thing is, BFD doesn't take a lot of overhead. So like I said, this works outside of the protocol. And what we will have to do as well is we would have to actually add this to, like I said, the interfaces as well as the BGP configuration itself. So let's just do this real quick. All right. We know that this here is BGP Autonomous System 104. And what we will do is we will add BFD to the peer, which would be 10, the 10 network. And just for safe measures, we can do the same thing to the 15 network. Okay, it's not a problem to have them on both. Now, if you're going to have them on both, we also need to have this corresponding to the interface as well. And as you see here, we got it on fast ether 0, but let us check, and we need to put the timer on fast ether. Well, we got it on number 1. We need to put it on fast ether number 2, fast ether 0. I'm sorry, the second one. So we'll do that there. Do a quick check. Show run interface fast 0 and fast ethernet 1. Show interface. Now we want to do a show run section BGP. And what you will see is that our BFD failover statements are in there for both networks. So we'll come to the peer and we'll do the exact same thing. We'll put the timer in fast ethernet 0. Just copy that. And then we will go into the router autonomous system, which is router BGP 103. And we will add those networks in for the 10, the failover for the 10, as well as the 15. Do a quick check. We have our timer, 50 milliseconds, multiplier 3. So we're looking at 150 milliseconds as far as these echoes going back and forth across the network. Okay, we do a run section BGP, and we see we have our BFD neighbor failover statements in there as well for both the networks. So let's go ahead and kick this puppy back up. Let me see here. Make sure I got this interface open. Let me open that back up. Okay, we'll give BGP a second to come back up. BGP is up. Okay. Now what I will do is I will repeat that extended ping that I had, and I will get this here ready for shutting down this link again. Okay, there's the link, and there you see how quick that converged. So that was extremely fast. Extremely fast. So what you see is it tells us BFD adjacency is down. So basically, those super fast pings went out to its neighbor, realized wasn't getting a response, and it told the BGP process, "Hey, buddy, look, ain't there's no need for you to wait for your hold timer because the other end of this link is dead. So you need to reconverge now. You don't need to wait for the timer." And that's exactly what happened. Now, let me just take a quick look at, let me see here. Looking at packet tracer, one thing I can tell you is that just in that short period of time that we did that, you will see exactly how chatty BFD actually is. So let me put this filter on here. Okay. So you can see here in that very short period of time from when I did the actual BFD test, you can see as I'm scrolling through, we have a lot of packets, almost 13,000, over 13,485 packets. So that's one thing you may want to keep in mind as far as how you adjust your timers, because as you see here, BFD is a very, very chatty protocol. Okay. It's it does what it does. It's good at what it does. And like I said, you use this mechanism to fine tune your network for those failures, because like I said, if botch and see, this is just this was a simple topology. You know, we're talking two routers, two links, and that was it. But in the event that you got multiple routers, multiple failures, uh, and if you're running BGP, you could be sitting there waiting for a long time for things to reconverge. You know, it's known that BGP is not one of the fastest in the bunch, but you get the point. And BFD can definitely fine tune your network when it comes to detecting those link failures and then getting your router processes to reconverge on a different path to get you back in line again. All right, I hope that demonstration made sense, and talk to everybody next go around.